can we start or?
So we can. 14, 15.
Others are that we can wait for
So
another 2, 3.
15 people are there. I just put up the announcement regarding socket programming. So some more people, as they see the messages, they will be joining. We already have the recording.
Okay,
They
I'm
can.
waiting for another 2 minutes. They
Okay, sir.
can join.
Okay, sir.
Okay, that's enough. 16. So, good evening to all of you once again. Today, as I mentioned, that we will study socket programming. So, before studying socket programming, I want to give you a brief introduction about this. Am I audible to all of you? Can you
Yes,
see
sir.
my screen?
Yes. Yes.
Okay. So suppose means the requirement of socket programming is that how it comes into though means initially it came into existence for operating system, the sockets and all. Even in operating system we use this a lot. The idea is that whenever two processes are there, two separate processes are there, and you want them to communicate, you want both of them to communicate somehow, so then we ensure it through the creation of sockets, and then through sockets those two programs communicate. You might have heard about that in programs in operating system, either two processes can share a common memory, then both the programs can share that memory, and through that memory they can interact with each other. Or this is the way that they will create the sockets. So one process will create a socket, another process will create a socket. And socket is nothing from programmer's perspective. Socket is a sort of a file, and you will handle that file through a file descriptor. If in Unix you talk about any input output thing, if anything you handle that generally been handled through files. So we in a logical construct we always think in Unix everything as a file, and we handle those files through file descriptors. So socket is also a sort of a file. So one process will create one file, and another process will create another file, and through file descriptors we will then handle and ensure some sort of communication. So socket from programmer's perspective is a sort of a file which we will handle through file descriptor. So you can use these sockets to ensure communication uh, in between two processes, and those two processes can be the part of same host or same machine, and those two processes can be the part of different machines. So it doesn't matter where those processes reside and operating. We can use the concept of socket just to ensure a kind of a communication in between them. That is the background of sockets, and here for our programming we will use that two processes. We will go with the concept that two processes are residing in two different hosts, and two because we are dealing with network. So it's a distributed system, and in distributed system one host is operating one process, another host is operating another process, and then those two processes wants to communicate. So those processes are the application layer, and those two processes wants to communicate. How we will ensure it? So we will ensure it, as I have mentioned, that each and every process will create a socket, and then those two socket, always the process would communicate with the underlying layer uh, with and through that socket only. Yes, any issue? Hello?
So we can hear clearly.
You can hear me?
Yes, sir. No issues were there.
Okay. Some on my end there was some issue.
Okay, sir.
So I was mentioning about sockets. So here we'll go with the type of socket. How types of sockets are there? So how many types of protocols are there at which we have so far studied with respect to transport layer? So how many protocols we have studied at the transport layer? Anyone of you want to disclose the name of those two protocols which we studied at transport layer?
TCP and UDP.
TCP and UDP, yes. So we have used, we are going to use two protocols. By and large, mostly in network, we will use TCP and UDP protocol at the transport layer. So with respect to TCP and UDP, what we are using at the transport layer, we have the names at the socket level. So what type of a socket is, if it is using TCP protocol, then it stream socket. So whatever the properties you can associate with the TCP protocol, that it is reliable, it will always ensure in-stream delivery, it will ensure error control, all those features which comes along the TCP, you can always associate with the stream sockets. So socket with respect to the socket which is going to use TCP protocol are called stream sockets. Then comes the datagram socket. Any socket which is going to use UDP protocol. So anything which we can associate with UDP, which is unreliable, it is not going to ensure any error control, all those things we can think about UDP goes very well with the datagram sockets also. So datagram sockets are going to use UDP protocol, and stream sockets are going to use your what TCP protocol. That means two processes wants to communicate. Now they definitely require any transport layer protocol. So which transport layer protocol those two processes are interested in? Based on that, they have to create the socket. If they are interested in TCP protocol, then they have to create a socket for TCP protocol. They have to, while creating the socket, they have to ensure, they have to write somewhere, they have to mention it that this socket is of type string. Likewise, when they are going to use UDP protocol, then also they have to ensure that this is a datagram socket. Now, if apart from these two protocols, you are interested in some protocol for research purpose at the transport layer, you come up with your own transport layer protocol, then whatever the socket you will create, those sockets are called row sockets. This is for your interest purpose, your research purpose. So for that purpose of a socket which you will create, you have to mention those sockets as row sockets. Then those sockets will operate based on how you will design your TCP protocol, transport layer protocol. Now, because we are interested in distributed systems, so here we are using the concept of client and servers. So we are not interested in in-house communication or on-host communication on a single host, two processes. We are interested in two hosts and the communication in between them. So one host is a client and another one is a server. Now, many of you are aware of that what type of servers. So one is iterative server and another one is concurrent server. So can any one of you just by the name can explain what is iterative server? Huh? I mean, these are self-explanatory. Yes.
One client per request. It's like it will do one thing, then end it, then other.
Yes. So iterative server, as the name suggests, it will serve the client in iterations. So whenever the request comes, it will enqueue those requests, the client request. And as in the queue, it has enqueued them in the same order, it will relieve them. It will process those requests. Then comes the concurrent server, the opposite of it. As and when the requests come, it's been handled. So the best way of handling those things is so you create one more child process, which will be with respect to the request. So whenever the request come, you will fork a new child and that child will handle it. Another way is instead of creating a child, you can have a threads. So through threads also you can ensure the service corresponding to those requests. So these are two ways through which we can create concurrent servers. So in today, we will just go by the iterative servers. In our next class, we will see the concurrent server design, how we can do that. So as I have mentioned in two ways, either we will fork a new child or through threading, we will ensure the service at the server end. Now in the iterative server, we will deal with two type of server. Even in concurrent server, we will do one is TCP server and another one is UDP server. So in one we will use the stream socket, in another we will use the datagram socket. So today we will just focus on the stream socket. So now how to implement this is important. If you would have if you will understand this thing as I will progress, so it will be easier for you to understand the program. So I'm showing you the program first so that you will focus on what. So this is the program at the server code. You can see this is the server side code. So this program is for, it's an echo server. So the client will tell something, will give one file in something, it will send to the server, the string it will send to the server, and server has to echo it back. So this is the server side code, so you can see, and then the client side code. So you have to write two codes. As while mentioning the socket programming in my theory classes, I have disclosed that you have to come up with two programs, client side program and the server side program, because it's a distributed programming, distributed system. So server side program will run at the server side and client side program will run at the client host. So these are the program. Now we will try to break down the program and understand that what is going on in this client side code and server side code. The requirement is the two processes are there and those two processes wants to communicate. So here in the echo program, the echo server, the requirement is that the one program, the client side program will request the server that this is my information, this is the string, and the server has to look at the string and then reverse back with the same string. Now this is a small program. You can do anything with the server, means you can request for anything and the server can go to that request and serve it based on your requirement. So you can program it to any level. So the basic fundamental idea is that what you are requesting, you are getting a response corresponding to that. So that's how you will code your program. So that goes with the logic which you want to serve. So we will not go by the logic based on the programs that will change. So the idea is that how the connection setup phase will end up and how the request will be processed and finally being returned back. Then based on the requirement, you can change the logic. I will give you certain sample codes as well so that you can work on those problems. Now I will break down the client side and the server side, that exactly what we will do. So whenever you have to create a program, whenever you have to write the program corresponding to the client side, how you will implement the client side. First thing is that, as I have mentioned, that you require a socket, because that's the socket which will ensure the communication. So you will obviously create a socket. So here the first at the client side, what you have to do, you have to come up with a socket. You will create a socket. So we will use a socket system call. So we are here using Linux API, and the sockets which we are dealing with, Berkeley sockets. So in general, we can name them the sockets, but there are other type of sockets also. But here we are using the Unix type of socket, the Berkeley socket, and the Linux API we are using. So socket, this system call, when we will invoke this system call socket, it will return a file descriptor corresponding to the socket. It will return a file descriptor. File descriptor is nothing, it's an integer data type thing. So in any integer variable, you can take the file descriptor. The socket will return that. And after the creation of the socket, then we can go ahead. How we will go ahead? Now at the client side, you are interested in the connection. So first you have to establish a connection. As in the TCP, I have mentioned you that in TCP, initially, because it is a connection oriented, client has to convey to the server that I'm interested in connecting with you. I want to go ahead with communication. So initially it has to convey the connection request. So this is the connection request. So through connection request, obviously within this connection request, there are certain arguments. Later on, we will see that what arguments do you require in the connection system call. So then we will use the connect system call. All these things we have to write in sequence. We can't deviate from the sequence. So because until and unless you have a socket, you can't invoke connect system call. So initially we will create a socket. It will give us the file descriptor. Then we will handle that socket through that file descriptor. Because how we have to handle that socket, we have to give it a port number. We have to give it an IP address. That is the complete socket address. The socket complete address is its IP address and its port number. So through that file descriptor, we will handle that socket. We will give it its proper address. Then we will connect it. So we will inform through this connection system call that the client is interested in you. So then server will handle this connect request through another system call. That sequence also I will let you go through. Then once the connection is over, then we will simply use read and write or send and receive. So these system call we can use. So either you can read or write. So then because how we are using simply the read and write, because socket is nothing but from programmer's perspective, it is simply a file. So over a file, we are either writing something and reading whatever is written there. So whatever you will receive there would also be written on your socket. So then you can read through read system call, you can read it. If you have to send something, then you can write over it. So you can simply use the write system call. Read and write, or receive and send also you can use. So those are also system calls. And so this is just about the client side. It is simple to code for a client. Now at the server side, it's a bit complicated. First is that you have to create a socket. At the client side, once again, I'm briefing you reminding you, we will create a socket, we will then go for a connection establishment, and then we will continue for our read and write, whatever we want to do, whether we want to read something or whether we want to write something, then we will simply use the read and write system call. So it is simple. Now here at the clients, I mean at the server side, obviously the first and the foremost thing is the creation of socket. You create a socket, you take its file descriptor in the integer variable so that we can handle with the socket. We can give it a proper name, its port number, its IP address. Then we want to ensure, because at the server side, you know that the server ports are fixed. If we are using the web server, then the port number is 80, it is fixed. If you are using DHCP server, port number is fixed. So if you are using any server, their port number is fixed. So we want to convey it to the operating system that we are stealing this port number and we want to bind it with this socket which we have created just now, because it is a server who will do specific this work, and all across the world people know this server by this name, by this port number. So it's better you give it away to us so that you will not reassign to any other client port number. So if any, because on that system also it may be possible that some other servers are operating or any other process is operating which wants to use socket. So operating system will randomly pick. So if you will not bind that, then operating system can reallocate it to someone else as well. So you want to convey it specifically, categorically to operating system that we want to bind it, so that you will not no longer be able to reuse it. So that is the bind concept. So in bind, what we will do, just now whatever the socket we have created, we will give a proper port number and IP address, and we will bind it to that file descriptor. Or then the next one is, okay, we have given the port number, IP address, everything we have given to our recently created socket. Then the next one is, because you are at the server side, you have to passively listen. You have to always listen to your interface that any request is there for you or not. So for that purpose, there is a listen system call. So then you will invoke the listen system call, and everything should be in sequence. First, you will create a socket, then you will bind the address and the port number, everything to that socket. And the third thing is, then you will start listening to the request, whether the request been there for you or not. Then you will keep on listening. Then there comes the accept system call. This is with respect to the connect. So whenever at the client side the request would be invoked through connect system call, then this would be entertained by the accept system call at the server side. So server would then accept it. So with respect to connect, there is an accept system call at the server end. So whatever, I haven't explained the three-way handshaking, though I have named it several times during theory classes. So whatever I will explain in the handshake phase, so that thing would be taken care in programming through connect system call and accept system call. So connect and accept would ensure the connection establishment in between these two client and server entities. Once it is over, then it's well and good. Then you can go ahead with read and write. If you want to send something, you will use write. That thing would be written on the socket, then it will go to the client side. If you are interested in reading something, you are expecting that now something is about to come, then you will invoke the system called read. So that's how you will program. So that is the part of logic. These read and write, where you have to write, read and write, this is all about the part of logic, which depends on the requirement. But before read and write, everything must be in sequence. Any questions so far? Anything you want to ask? Hello? Hello?
No, sir.
Okay.
Sir,
Yes.
if it is peer-to-peer communication, this accept should be even in client also, no, sir?
what I'm just mentioning client server architecture now. If you are using peer-to-peer, that design perspective is completely different. So I'm not mentioning here peer-to-peer architecture. It's client server architecture.
Okay, sir.
Then comes, this is through the diagram, the same thing in TCP stream. First, at the server side, you will create a socket. Then you will bind that socket with its address. Then you will invoke the listen system call so that it will keep on. This is also in other term called the passive activation. So you have passively activated the server. Then with respect to the connect, so at the client side, you have created a socket, and then you will invoke connect system call. So connect, there is an accept system call which will take care of this connect request. Then once the connection being established, you have synchronized both the entities, then you can go ahead with the send and receive. So here client is sending something, you are receiving, then you are sending something, client is receiving. Then finally you have to close the connection. So here closing means then uh, the closing, and then as an argument here you give the file descriptor of that socket. That means it can be then reused by the operating system. So then that file descriptor would no longer be valid. So those port numbers and address which have been assigned to it can be reused. That is the idea behind closing this. So socket descriptor I have mentioned. So socket descriptor is nothing but it's a integer data type thing. Then means it's a sort of an identifier to that file which you have created as a socket. So it is that descriptor, file descriptor. Then the socket address, as you know, socket address involves what? Your port number and IP address. And then along with this, because these sockets are, when those sockets were created initially, so those sockets were for in-house communication or on-host communications also. So on a same local communication on a same machine also. So they have to define the address type, because for network we are using the IP address. So somehow while mentioning the address, while mentioning the socket address, somewhere some field should be there that what is the address family, whether you are going to use the IP addresses, IP version 4, or even in network addresses you are interested in using IP version 6 address, or for local communication the address type is different. So for that purpose, while mentioning the address, somewhere some field should be there. And how we are going to maintain all these things? We are going to maintain through C structures. So we will create a C structure where we will write all these information in those fields, the field of structures. So in that structure for address, there is also one field that defines the address family, whether it is an IP version 4 address, IP version 6 address, or local communication, this kind of thing. So these are the system call: primitive, socket, bind, listen, accept, connect, send, receive, close. So I've given you an idea regarding this. Now these are some of the structures which are well defined. We are going to use them as it is. So in Linux, these are well defined. So the Linux operating system, in that in their coding they have already used it. So we have to just reuse it in the same form. So first is struct. The address is also this, the same address. The socket address. So this is the structure for socket address. And so this is the generic socket address. It is not specifically for internet. So this is a generic socket address. First is what is the address family, and then whatever be the data of 14 byte of protocol address. So whatever be the address you want to give, so all that thing comes as a one data part. So it is a generic socket address structure. We will use this kind of structure, struct socket address. You can always typecast, you can typecast this socket address for internet to this socket address also. it is permissible. So this is struct socket address in. So the structure is short integer, its family. Families you can choose from these. AF Unix if you are using local communication, so means on a same machine two processes wants to communicate, then as an argument you have to give AF Unix. If you are interested in type 4 IP version 4 internet protocol, that means 32-bit address, then you have to give AF internet. If AF stands for address family and INET is for internet. And if you are using IP version 6, then it is 6. If you are using these protocols, so then AF, IPX, novel protocols. So we are interested only in IP version 4 interest. So you have to just remember AF init, internet, address family, internet. So in this structure, which is entirely constructed for internet type of address, so struct socket address internet, there are two items to it. First is the family. You have to define what kind of a family, and three things are there. There is also one more thing, unsigned short int port number, because in address what is there, port number and IP address. So one is port number and address. The specific thing which is specific to it and different is the family type. So you have to mention the family type as well, because in address generally we consider the port number and IP address. Along with port number and IP address, what type of a family address those addresses belongs to, that also we have to convey. So these three information goes as an item type to structure socket address internet. Then this third type of internet address, you can see this is also one structure type of struct internet address. So struct internet address. So this is for IP version 4 address. So they have constructed one more structure specifically for IP version 4 address, which is also the part of item type of socket address in. So struct in address, it has only one item, that is unsigned long integer S address. So S address will contain IP version 4 address. That's all. So you have to remember only these two structures, their type as well as the content items, which are the part of these structures. So only these two constructs you have to remember. All across our program today, we are going to use these structures. So what goes as an item to these structures, you should remember. So in socket address specifically for internet, not for the generic one, there is also the generic one socket address. This is specifically for internet. So for internet, one is the family type, what sort of a family it is. So here there we will always write AF INET, so AF underscore internet. So that is the family type. Then we will mention what is the port number. So then we will write the port number. So second is the port number detail. And then third one is SYN address. That is another structure type, where in that structure type S address will contain the IP address. So we have to write will any one of you tell me that if the IP address regarding this socket address is 127.0.0.1, how we will write that thing? For this SYN address, how you will write that IP address? How you will mention? You have, your smart in programming. Tell me how we will write that IP address. We have recently constructed a socket. That socket, we want to give its port number. So the port number is 100 port number we want to give to that socket. Address type is AFINET, and the IP address is 127.0.0.1. So how you will ensure that thing? You know it all. Okay, then. Then comes on this major thing, because when two hosts are communicating, in our last embedded system also, we understood that there are two type of machines, little endian and big endian machines. So if suppose one process is running on little endian machine, another process is running on big endian machine. So in that scenario, there would be a mismatch. So whatever I will share with another party, another process, that process would not be able to comprehend. So how we can ensure it? So whenever two process wants to communicate through network, they are not on the same host. It is not a local communication. In that scenario, whenever they are interested in network communication, they have to always convert whatever be their type to the network byte order. So in whatever way they have stored in their memory, they have to always convert that storage type, whether it is a little endian storage type or the big endian storage type, they have to always convert it into the network byte order. So that there would be, everyone knows that whatever we are receiving, is it in network byte order. So if you are using little endian, then you will reconvert it into little endian. If you are using big endian machine, then you will reconvert it into big endian. Now what is network byte order? Network byte order is nothing, it is exactly like big endian. So we are renaming the big endian with respect to the network as a network byte order. So it is very good if you are using the big endian machine, then you don't have to convert it into network byte order, because anyways whatever is your configuration that suits the network byte order, it is exactly the same. Whereas if someone is using little endian machine, and if they want to communicate with anyone, because they are not aware that with whom they are communicating is either using big endian or little endian, so it is always advised to convert their whatever they want to convey into big endian first and then send it all across the network. If someone is of little endian who has received it, would reconvert it into little endian, or if it is of big endian, then no issues. But here in case of the network, we are naming it as network byte order instead of saying it as big endian. But big endian and network byte order is exactly the same thing. So to convert it, there are several functions, the system calls, which we can invoke as and when we require. So suppose if you are sending something, so you are a host and you want to send it to the network. You're not aware that who is the next party. So what you will do, host to network. So H2N in short, so short data type, H2N in long if the data is long. So H2 host to network long. So if some sender is there, sender would invoke host to network either in short data type or the long data type. And if you have received, so if you are a receiver, then in that situation you will invoke these two system call. If the item is of short data type, then you will use the network to host short, network to host long. So these four you have to remember. Then one more thing, interesting thing is that we are dealing with IP addresses, and as humans we are more comfortable with numerical digits. So because 32 bits we can't remember, so we use the another representation that is called dotted decimal, like 127.0.0.1. But our network and the network machines, they understand only bits. So how to convert it? How would you convert when you will send your IP address to the network, so that the network entities, that means the routers, can understand what you are saying to the network? In that scenario, you have to use one more this function, either internet address, and if you will give as an argument the dotted decimal argument, it will convert your host address, whatever the address you will give as an argument, to bits. And these are same, you can also use this ATON also, address to network, init address to network. So these things you have to remember for programming, just these things. So these are the basics. Now we will move on to our program, the system call. So one by one, I will mention about the system call and the arguments they will take. So first is the creation of the socket, how you will create the socket. So while creating the socket, then you will mention the family. Family is nothing, I have mentioned you that what type of communication addresses you are going to use for your communication. So in that scenario, either it could be a local communication or it could be for IP version 4, IP version 6. So here always we will write AF in it because we are interested only in IP version 4 here in our programs. Then what type of socket it is, whether it is, there are three types I have mentioned. So in our program, we are interested in only two types, either the TCP type or the UDP type. That means either the stream type or the datagram type. So if you are using the stream type, then the argument name is, which we have to always confirm with, and you have to always use these caps: socket stream, sock underscore stream, or if you are using the UDP datagram, then you have to write as an argument socket, means sock underscore datagram, dgram. So this is all about the type. Then protocol, this is specifically to write either the TCP protocol or the UDP protocol which you are going to use at the transport layer, but you can leave it blank as well. You can mention 0, the default value, then the operating system will consider itself based on the type, that which protocol it is going to use, because the prerogative is on you can direct operating system, but always the prerogative is lies on the side of operating system, that which protocol it is going to use. But here by default in our program we will write 0 default value, so that we are not forcing operating system to always use that. It is based on the operating system requirement, it can change also. So if you're not interested in forcing the operating system, then it's better to write the default value 0. Then based on the type, if everything is permissible, everything is within the reach of operating system based on the resource and requirement, it will adhere to your request. So this is all about the socket creation. So it has three arguments. First is that we will always write the family type, what type of an address we are going to use. So if you will create any, so here I'm mentioning the local communication. So if you are creating any project in which you are interested in two process and want them to communicate, then in that situation you have to use the family type with respect to the local communication, how local communication addressing you are using. So then the family type goes, I think, AF underscore Unix. Process to process communication. But here we are interested in network communication, so we will write the family type because here 32-bit addresses we are using. So IP version 4. So that is AF init. Then comes the bind. So at the server side, when you have created a socket, or at the means at the client side, it is not that we can't bind at the client side to any port number. We can always do that. So bind is, in general, you can understand that bind is something a system call which will reserve those port numbers so that it cannot be reused by the operating system. So how we can do that? Bind. First is and as I have mentioned, socket is nothing but a file, and you are handling that with respect to file descriptor. So you have to give the socket ID. That means the file descriptor to that socket. So first is that argument. Then the second one is, what is the address? What is the address? What is its means what address and what port number you want to reserve and want to give it to this socket. So this is that structure, address port. So somewhere this is of that address type of structure where you have already mentioned in its field that what is the port number and what is the address, IP address. So it is an address to that structure where you have written all the addresses. And then what is the size of that structure? So that is the third argument. So where you have written the IP address and the port number in that structure. So what is the size of that structure? So that goes as the third argument. So first argument is the socket ID. where means so where you want to give the address, you want to bind that address, then somewhere in the structure you have written the address, the port number and the IP address. So that address you want to bind with this socket ID. So that goes as a second argument, the address to that. And size of that structure. So these are the three arguments which are the part of bind system call. Then listen system call. In the listen system call, we will mention that on which socket we are listening. So that socket ID anyways we have to give. And then we will give one queue limit. If you are using the iterative server, then at a time, how many things can be queued in a queue. So how many things can be n queued in a queue. So that queue limit you have to give. So what is the limit of the queue which is associated with that socket, so that your server can enqueue them. So these two details you have to give. Then comes the connect system call. So with respect to the client, when client wants to connect with the server, so client will so communicate with some other socket. So you have to give both the addresses. So first, the first socket ID, your own socket ID. So this socket wants to communicate with some other socket, then you have to give that socket address, that where you want to communicate. So this is the foreign address. That means on the port number 4. If client wants to, with respect to client and server, server is foreign to client. So there you will mention what is the port number with the IP address. So that address you have to, and then finally the address length. This is all parameter. Always third argument. What is the size of the address structure where you have written the foreign address. So this you can see the address length is nothing but the size of foreign address. And foreign address is nothing but it is a structure which contains port number, IP address, and the third type is what is the family type, AF in it, that we will write. And then the second thing is port number we will write, and the third thing is IP address we will write. So wherever it is there in the memory at the client side, so you have written that foreign address, and then as a third argument comes the size of that foreign address. Then finally at the receiving end, means at the server side, with respect to the connect, how would you accept? So as I have mentioned with TCP, if you can recall, there are two type of at the server side. If you can recall, there are two type of socket. One type of a socket is always on, that is a listening socket, which will always listen to the request. And whenever there comes a request, after handling that request, after setting up a connection, it will invoke one more, it will create one more socket specifically for that client, which has requested that server to serve that client. So here in accept, we are dealing with the TCP stream, the TCP establishment of the connection. So in TCP establishment of the connection at the server side, server is listening passively on one socket that is entirely for listening, that is entirely which we have created initially. So initially we will create with the server side one listening socket which will always listen passively, which will always be active, and whenever there comes a request, that request would be handled on another socket. So there would be a creation of new more socket, one more socket would be created specifically for that request, which is going to be handled by that server. So how that accept would then entertain the connect system call. So it is a socket ID. So it is the same socket ID on which server is listening, and then it will look for the client address, and the address length means a pointer to the address length of the client address. So client address is nothing but client address is same. It is a structure which contains the detail corresponding to client IP address and the client port number. which it has taken from the connect system call. So through connect system call, it has taken these details, and then the address length. Address length is exactly the same, what is the size of this client address. And here, instead of directly writing it here, we will store it somewhere, and then we will write the address to that storage. So address means ampersand address length. So this will goes an argument to the accept. What accept will give you in return? So what it will give you in return? It will return the new socket ID. That means it will create one more file, and that file means with respect to the socket, it will create one more file, and it will return you a file handler, the file descriptor. And that file descriptor we are taking back in the integer variable new socket ID. So with respect to each and every connect request, accept will give you the new socket ID. Now each and every, the read and write would be going to use this new socket ID. We are not going to use the previous socket ID for reading and writing. Now how you will send and receive. So once connection is over, everything is well under control. Then after that you will start communication. How you will start communication? So you're going to send something, you're going to receive something. So how you will send? So initially the first argument to the send is which socket is about to send. That means your operating system to know that which file to read. So you are giving that descriptor to your operating system in the send, that this is the socket ID, that you have to look into this file. So this is the handler to this file. So this is the socket ID. Then what is the message? So anything you want to write, then whatever be the message, that message you have to write. Then message length. So here you will, the message could be any buffer, anything, wherever the thing is there which you want to send. Then the message length is there. What is the message length? And flag. Flag is used for certain other options. So here we are going to set it as 0. So those, we are not dealing with other options, that how you can means options means some special other functionalities. So we are not dealing with those special functionalities with respect to send system call. So we will set it as 0 always. Now what it is going to return? It is going to return that how many byte it has sent. So in count, you will receive the number of byte your send system call has sent. Now in the receive system call, socket ID. So with respect to which file descriptor you want to handle. So what is the socket through which you want to receive, on which you want to receive. Then the receive buffer, where you want to store. So you have to give that receive buffer. Then what is the buffer length? Then what? So these receive buffer and this message is for reading and writing. So you have to store it. You have to give the location. So when you are sending something, so socket is a sort of a logical construct. It is there. Application is going to deal with this file descriptor only, but you require some location where this socket descriptor would read the message and then send it. So that location should be there. So in case of the send, it could be any buffer, it could be any array, anything you want to send, it could be any string, so anything. So that location you have to give as an argument in send here, and then its length, whatever be the entire length of that message. Likewise in socket, when you are receiving it, so this socket is handling the receiving, but where after receiving it will store it, so that you can read it and you can print it, you can do anything with it. So that location you have to give at a receive buffer and whatever be its length, and then the flag is for that other option, special options. We will set it as 0 here as well. Then finally the close I have explained, that you will just give the socket ID so that your operating system can reuse the assigned details, the port numbers and IP address to someone else. Now if anything goes wrong in any of these system call, it will return -1. So if you want to handle the errors, so you can handle the errors as well. So if any system call you are invoking and you are getting a return of -1, then you can handle it suitably. So that's all about all the system call. Now we will go to our solved example and see that how the program, instead of example, I will show you the program, the server program, this, and the client program. So server program and client program, here it is more simple. So what I'm doing here, client will send you something. So here what client is sending, whatever you will type, so client will send it to the server, and after reading from the server, server will if you will, means one character I am handling. So at the client side I am sending, like suppose A, then server will return me B. That's all. The logic is simple. So client will send one character, so and server will receive that character and send the next character. If you are sending C, then you will receive D. So that's all. See how this program will function. Initially I will show you how to run the program. So in this way, simply you have to write two files. You can write in any editor of your choice. You open the editor, you write the program, C program, client side, server side, two program you will write. Then we will open one terminal. Now you have to just compile it. So initially we will compile the server side program. Server, it is 2.c. You can rename the output file. I am using S. Okay, then I am compiling client 2.c. I'm renaming it as C. Okay. First you have to always run the server, because server should always be on. So I am running server. So server is waiting. Open one more tab, terminal tab, and then run client. So it is asking you to type a character to send. I am sending F. It has sent me FG. Okay. Once again, if I will run it, it is asking me to send something. I'm sending K. It has sent me L. And what is going on at the server side? Server is waiting initially. So who has requested me? IP 127.0.0 has requested you on this port number. So that was the port number initially of the client. Then the client side has changed the port number to this 42713 with IP address this, and server is still waiting. So server is always on here. Once again, if I will send A, it will send me B. Okay, so that is simple program. You can always change the logic. Now we will go through these two programs and see what is there in this. So these are the some files which you have to always include. So these are header files which you have to always include: type.h, system type.h, then socket.h. So most of the things are there in socket.h regarding the socket creation and all. Then this you all know, standard input output. Then this is also for our purpose. This is for that purpose, for converting your internet address to the host address, means in bit forms. And then this is also for some internet purpose. I mean, simple files are there. These are specifically for the socket.h, network internet, this ARPA init. These are 3 or 4 extra files which you have to include. These will give you an API for this programming. So whatever the structures and all we have seen, those things you can directly then use. You don't have to then construct it in your program. You can reuse it. So this is the driver program, main program. So first is this server socket. So these are our file descriptors, which will hold the file descriptors. So server socket FD file descriptor, server side file descriptor, and client side file descriptor. So with respect to the client side socket and the server side socket, where their file descriptors will go. So it is of integer type, we know. So these are two variables. Then integer server length and the client length. So this is, as you know, that always in most of the system calls, the third argument is the length. What is the address length? So this is with respect to that what is the server length, server address length, and what is the client address length. Then these are the structures which will hold the client side address as well as the server side address. So socket address in, so this is the same structure which we have studied recently, socket address in. So this type of server address we have created one structure. Likewise, we have created another client structure. What we will hold in these structures, we will hold three information with respect to server address and client address. With respect to server address, we will hold what is its family type, whether it is IP version 4 or 6 or local communication. That detail we will go there as a family. And another one is what is its port number, and third one is what is its IP address. Likewise for client as well. Now, as you know, at the server side, first and the foremost thing is server creation. You have to create a server. So this is the server we have created. So server creation require a socket system call, and socket system call has three arguments. First argument is what is the family type. So AF init, that means we are going to use IP version 4. Then which transport layer protocol you are going to use. We are interested in TCP, so you have to mention the socket type. What is the type of socket? So it is the socket stream. You have to mention socket stream. And third is the by default, so we are not giving any protocol. We will let operating system to decide protocol on our behalf. So that's why we are giving the default value 0. Now you have created the socket. Obviously, after creation of the socket, you have to give the name. That means the address, everything you have to give to that socket. So you have created the socket. Now in server address, this is the server address. This is the server address. Now we will fill this server address. It has three informations to fill. How we are filling this information? Server address dot syn family. Server address dot syn family. This is of AF init type. That means we are going to use IP version 4 address. Then server address dot second argument is its address. What is the address type? And that address type in the server address means in the server first structure, it is a structure again. So you have to once again one more dot. So in syn address dot s dot addr. Is it clear to all of you that why these two dots are there? Because the third argument in syn address means socket address underscore in structure is of structure type, which holds finally the IP address. Is that clear to all of you? Hello?
Yes, sir. Yes, sir.
It's programming, it's very well evident. So then we are converting. So this IP address we want to give, but directly we can't give it. We have to first convert it into bits. So who is converting this INET underscore ADDR, or the second function also you can use that ATONS, I think. INET underscore ATONS. So that function also you can use. So this thing you have given. Then the third one is 9734. It is of your choice. You can give any port number. So this port number we have given to server. So this is with respect to naming regarding server. We have named the server in these three lines. We have given the proper address family. We have given the proper IP address. We have given the proper port number. So after giving them proper port number, because as an argument, we always require the size of this structure. So we have taken the size of this structure, server address size of in server length. So this is integer type server length. Now we are interested in binding this. we are interested in binding that whatever we have given the address, we want to bind so that your system, your operating system can't reuse it. So we want to bind it now. So after binding, it requires 3 arguments that where you want to bind and which address you want to bind. And the third argument is what is the length of that address which you want to bind. So first argument is server socket FID. So this server socket function file descriptor. So that is the socket ID where we want to bind. Now what we want to bind. So this is that pointer. So this is the pointer to that address. Is it clear? Or do you want me to explain that what is going on here? It is a pointer to that address which is holding the information regarding the server address. So server address, you know, server address is a socket address. Now you have taken after ampersand, you have taken its address that wherever in the memory it is stored. So first location of that. So that is a pointer. Now struct socket address asterisk is a pointer to that. So it is a pointer to that. And then finally, third thing is server length, which we have calculated using size of. So using this, we have created a binding. After creation of the binding, then we are interested in listening, because you have binded, you have created socket at the server side. Now you will listen. So listen, the first argument is on which socket you want to listen. So you will give that as an argument, and then you want to give what is the queue size, how many items, how many requests could be there in queue, which can be entertained by your server. So that is 5. Now we want to recursively do the operation. So that's why this while thing is there, while 1. If you will take away this while, then it will, the server will run only once, but we want to recursively run the program so that it will always be on. So whatever the operation server is supposed to do, it is always on to do that. So for that purpose, you are writing the rest of the code in while loop, while 1, or means whatever be the infinite loop, whatever the programming construct you want to use, either for loop or any loop you can use. So while 1, in that idea is, what is our idea? Now here you have to think about the logic. The logic is that you are interested in receiving something. The client will give you something and you have to then receive it. You have to then receive it, and after receiving, you have to operate on that received item. How you have to operate? You have to, if you have received A, you have to increment it to B and then send it. That is the logic. So while designing the server, you should be thorough with your logic, that what kind of functionality your server is supposed to do, what your server will do. So there we will go by our logic, that that's how we'll go about our program and its design. So here we are creating one space for holding that character. So char ch, we have created one space for that. Then anything you want to write on your screen. So printf server is waiting. Then here now we will accept a connection. So accepting the connection is, we will invoke the accept system call. Accept system call, who is accepting? So servers file descriptor would go as a first argument. So server socket first, this they have named it bigger. So it's a file descriptor to the server socket. Then the second argument is your client side address. What is the client side address? So exactly a pointer to the client side address where it is holding. So this accept is with respect to the connection. So at the client side, you are invoking this connection. So after invocation of this connection, and when it would be interfaced by the accept system call at the server end, because here you are sharing the socket FID. So here you are using the socket FID. So that is the client side socket FID. So using this, your server would come to know that what is your client side address, and then it will point to that. And then finally the address length. So this is the size of client address. and this client length is holding that value, that structure value, the size of that structure, and the pointer to it. So here that is different. In the previous case, it is not a. So here you can see it is directly the server length here, but here in case of accept, it is a pointer to that. So it is important to remember. So when you are writing a accept system call, it is a pointer to that size length, the client length. Then finally, here it is converting IP address, means it is taking the IP address. So now in the client address, the client IP address is there, the client port number is there. So as you have seen in my program, that here the server is typing these things as well, that what is the IP address and what is the port number of client. So how we can get to know what is the client IP address and the client port number, because now we have received all the details in our client address. So this client address structure, using this accept system call and through connection system call, so your client has sent all these details using connect system call, and your system, the server has accepted it using accept system call. And where it has accepted these details, it has accepted these details in client address structure. So it has filled, so using this accept system call, it has filled all the detail corresponding to the client. Now we can read it as per our requirement. So they have read it and write it simply. So how they have read and write it? So client address dot SYN address, and then they have converted it into network to address. So different thing. Instead of using A to N, they have used N to A, because now at the server you are receiving something. So when you are receiving, so from network you are receiving, from network you have to convert it into an address so that others can also read it. So it will reconverted the bits into dotted decimal. There you are storing it in IP address, and then likewise you are also retrieving the port number, which you are finally writing here. And after writing what you are you are invoking the read, because that is important thing. You are interested in reading something which client has shared with you. So read client socket file descriptor ampersand ch and 1. So this is the location where after reading you will store it. So this is the receiving buffer. So this receiving buffer you have already created in one space, you have already created. So whatever from the client socket file descriptor you have received, you are going to store it in this place, and this is the size. Third argument is the size of. The size here is 1, because ch size is 1 byte. Then you are incrementing it ch plus plus. That means if you have received A, it will be converted to B. Then you are finally writing it. So you have read it already, and then you are writing it. Writing, same thing, client socket fd ampersand ch. Now ch holds B, and what is this size 1. Finally we are closing the socket. That's all regarding the server side. Now at the client side, the idea is first we will create a socket. Second, we will straightway go for the connection establishment. And then finally, we will invoke our read and write operations. So it is simple in comparison to the server side. So I will not go into all these details. I will share all these things to you right now so that you can go through, and what I will assign you, you can do it. You have to just manipulate the same program. I will share the same program to you. You have to manipulate it for another program. I will give you different logic what you have to give. Just understand. So I'm not re-explaining all these variables at the client side. Finally, here the first and the foremost thing you are doing is the creation of the socket, and the socket arguments you know very well. After creation of the socket, obviously you have to fill all the details corresponding to its address. So you have created one socket address, means address which will hold all the details corresponding to that socket, and it is of type socket address integer, means for the internet type. Then after this, address means you know all these things already. I have explained. I'm not re-explaining it. Now one instead of means this address is holding here at the client side, this address is holding information regarding the foreign address. That means the server address where you want to contact. Client wants to contact to the server. So whatever be the server socket address, that socket address you have to store. Where you will store? You require once again the structure. Only in structures you can store. So this address is that structure at the client side, which is holding the information, what is the port number, what is the IP address of the server. So this address we will use as a second argument in connection. So here the second thing is that after creation of the socket, you are using the connect system call. In the connect system call, first is who wants to connect. So which socket wants a connection. So this is the client side socket function file descriptor. And the second argument, a pointer to that address, which is holding the foreign address, which is holding the server address. And which is, what is holding the server address? This address of type socket address in is holding this information. So this structure is holding this information. So this will goes as a second argument. And then the third argument is anyways, always the length of that address. What is the length of that structure? Now, if this result is -1, that means if anything goes wrong with the connection establishment, because things may go wrong in connection establishment. So if anything goes wrong, the connect system call would result -1. Now, one thing I want to mention, the connect and the accept system call. Connect system call and accept system calls are blocking system calls, whereas listen and all other system calls are non-blocking system calls. So any one of you who will shed some light on the blocking and non-blocking system calls. What is blocking system call and another one is non-blocking? Hello? Anyone who knows anything about blocking system call? Hello?
Blocking system call block the resource.
Block the resource.
Can be, but non-blocking does not. It just sends it, and then others can also access it at the
yes.
same time.
So blocking system call, what blocking system call will do, that suppose at the server side, if you have invoked a system called except, at that time no other system call can be processed. System until and unless would result back with respect to this system call is not going to give its resources to other processes. So that is a sort of a blocking resources, as Arpan mentioned. Whereas in case of non-blocking, that means others can also means system would not take care of that system call too seriously, as in the listen system call, that if one would invoke the listen call, system would straightway answer back, okay, I have taken your request. If other would give the listen call, also handle it at the same time without the resource. Whereas because it is a connection establishment field, why these two system calls are blocking system call? Because the entire communication, entire thing is dependent on these two system call. Until and unless there would be a connection establishment, things would not progress. So these are the critical system calls which will establish the final connection, and then things can go well. So at that time, system has to take care of these requests and give its resource entirely and focus entirely on these system calls and these requests. So that's why these two system calls are blocking system calls, accept and connect. Now once if everything is everything goes very well, then you will end up connecting with the server, and the result would be non-negative. Then if the result is negative and -1, then you will invoke that something happens wrong. Now here comes the logic, that the logic is you are interested in sending something, so first you will ask the client, the user, to enter something which you are interested in sending. So for that purpose, this is the logic, very simple. You will scan that thing, and then finally after scanning you will write it. So write means sending. So whenever you are writing, you are sending something. And this socket FID, over which socket you are sending, you are using the client side socket, the socket FID, and this is holding the value, and this is the length of that buffer. Now once you have sent, you have to wait. Once you have already sent the thing, then you have to keep waiting until and unless a response comes from the client. Then after this write, your focus would be on read. So you would be on this read system call, and recursively you will keep looking that whether you have received something or not. The moment you receive anything over this socket, then that thing will find its place in the same character space, and then whatever you want to do with that character space, or whatever, whether you want to show it or do something, anything. So here idea is to retrieve it back and show it to you, to the user. So here you are printing it again, and then you are finally closing the connection. Close socket ID, exit 0. So that is all about in simple ways regarding client side activities and server side activities. Once again, in brief, in nutshell, I am mentioning at the client side, you will do very basic. You will create a socket. Then after creation of the socket, you require foreign address where you want to contact. So you have to store the foreign details or the server address details somewhere in structure. So regarding that, you require some logic in your program. So that address you will maintain in that structure. Then you will invoke the connect system call. In the connect system call, there are three requirements, the three arguments. First argument is which socket wants to create. That means the client side socket number. So you will use the client side socket ID. And then the second argument is where you want to contact. What is the server address? So already you have maintained at the client side the server address in one of the structure. So that structure pointer to that structure address which is holding the address of the server, the foreign address you will store. And then third thing always is the length of that address, whatever be the length. So this is regarding the connection establishment at the client side. And finally, based on the logic, later on the logic that how you want to create, what is the logic of your program, what you want to request. So here the request is simple. So with respect to this request, you want user to enter certain detail. So then for that purpose, you have to write the logic for that. So you will receive something from the user. After receiving that request from the user, you will send it. So whenever you have to send, you have to use the function, the system called write, whenever you are interested in receiving, because the moment you have sent something, now the next one is you can't go ahead with read because nothing is there to read on it. So you have to keep looking that whether something is there to read on this socket or not. And because it is a distributed, until and unless your server will process your request, you have to be always on this system call, the read system call. You have to always look for something to read there. So this is the logic that how you will write, use the read and write, in which order you will write. So for that purpose, you have to construct the whole program and then deconstruct it in a way, in a timeline fashion, that what will happen at the client side and what will happen and when at the server side. In the same timeline order, you will write read function and write function. So as you can see that with respect to this write, so the server is initially expecting. So initially server is expecting something. So that's why here there is a read function. It is not straightway write, because here at the server side, you are expecting something to receive from the client. So that's why here in your timeline, if you will see writing read and write, the first thing in our timeline is the read function. Then once we have processed the item which we have read, then we will increment it. If we have read A, then we will make it B. So this is the logic for converting it into B. And then now the item is there which we want to send. Now for that send, we will write it to the server socket. and that will go across the network. Likewise, with respect to this write, so with respect to this, the initial read, we have at the client side write, first write, and then with respect to the server side write, we have a read at the client side. So that much check you have to ensure. That's all about server side and client side program. Okay, now I will share both the files with you. Your job is to create one more program. You have to make a necessary change in the same program, and those changes would be regarding. So I will show you the program. Means that. First requirement is, it is simple, that you have to create a daytime server. So client will request for day and time, the current date and time. If you don't know the function, you can go and Google the function in C, which you can invoke with the system call you can invoke, and will give you the current date and time. And so the request would be that you will write to one string at the client side, that what is today's date and time, and that string will go all across the server, and then server will return you current date and time, and at the client side then you have to write that the current date and time is this. So that is the first question. Daytime server, where client send request to time server to send current time, server respond to request and send the current time of the server to client. Okay, so this is the first, so these kind of functions you have to use. You can check, so it is the logic which you have to come up with. So this is the first program, daytime server. Next one is write a TCP which send sentences to server program. Server displays the sentence along with client IP and port number, which we have done right now. Server then respond to client by going in uppercase. It is also simple. So instead of characters, so I have shown you only for a single character. So if you want to deal with string, you require buffer, you require a string array type. So in that case, so anything comes to you, you have to just uppercase it. So if anything comes to you in small case, you have to convert it into uppercase and then send it. So that is, and one more interesting thing is that here I have shown you, once again I will show you at the server side. Whenever I am running this program and sending, like suppose G, it is not letting me use the same client again. So if you have to use the same client again without running it again, how can you ensure it? How can you ensure it is simple. So here program requirement is that until and unless the client side would specifically mention quit. So until and unless you type quit, you are supposed to reuse the same client program. How can you ensure it? Anyone? Hello? You just put all those logics in that infinite loop.
Yes.
Simple. And then make one check that if user has typed quit, then you will come out of that infinite loop. That's it. Then stop it. So these two things you have to ensure. So first, make this the same program for daytime server. So client will ask for a time, and server will respond back with current date and time, which you have to display at the client side. Can you do it? Any question? How many of you are there?
So 10, 11 are there. 12, sir.
Same 11 students are there. Initially 16 were there.
So it reached up to 20 as well.
Where those students went then?
Sir, after 7, they might have gone.
Even I didn't realize that I have spent 1.5 hours.
So it was
Started around.
going good. It is C
Okay,
programming, sir.
I am sharing this thing. So by 8 o'clock, any one of you show me the result regarding daytime server. So I am sharing both the files with you. You have to manipulate and change in the same file regarding daytime server. Okay.
Yes, sir.
So,
Or I think
what name?
before daytime you convert it for uppercase because that is easier if you will not be able to. Otherwise, that is also easier. You require one system call to retrieve the current date and time from the system, which you can Google that how to find the current date and time. So based on your own choice, you can go ahead with either the daytime server or uppercase. Send anything to the server and convert it into uppercase and then show it to the user in uppercase. So based on your will, you can go ahead with any of the program. Just give me one moment. Someone is there on my door. Then I will share both the files with you. Okay.
Okay, sir. Okay, sir.
So I have shared both the file,
Okay, sir. On files.
both the file with name. I'm showing you.
Yes, sir.
So it is under files with name socket. The folder name is sockets. And under socket, these two files are there: client and server.
Okay, sir.
You can download both the files and make necessary changes. It should not take.
Okay, sir.
So, daytime one only. Right?
What?
Date time has to be done or something else?
I mean, I have mentioned based on your comfortability, you can either go ahead with daytime server or uppercase. So client will share in lowercase and server will return back in uppercase, which you have to show to the user at the client side.
Okay, sir.
Ruhi,
So,
yes.
by when did you say we
What?
should complete?
By
when
8
did you?
o'clock,
Okay, sir.
Rohi, any question?
No, sir.
Have you understood?
Yes, sir.
Okay. Students are leaving now.
Sir, there were around 12 of them, then 4 of them left, I think, when the screen went blank. No problem, sir. Most of them have attended more than one and a half hours. So,
Okay.
yes, sir. So tomorrow we have at 8 a.m. the class, normal class.
8 a.m.
Yes, sir. So we have.
Tomorrow, I will teach only for 1 hour.
Okay, sir. Okay, sir. Okay, sir.
I'm not sure now. I am thinking of taking it only for 1 hour, but try to keep it limited because 1.5 hours is too much, even for you to
So
digest the thing.
we have CD exam as well, so it will start at 9:30. That's why.
Okay, one hour only then.
Yes, sir. Okay, I'll announce it on the class group.
So,
Thank you, sir. Is there anything else?
no, nothing. Yeah, I'm just waiting for you to do it.
Okay, sir.
Nikanti, can you?
Yes,
Whether
sir.
I have pronounced your name correctly, it is Nikanti.
Ketan, sir. Ketan.
Oh, Ketan. Ketan. Okay. So, have you understood questions? Hello, Ketan.
Yes, sir.
And in our program, why we are using this kind of special address 127.0.0.1? This address is a special address. I have conveyed the things regarding this address. I've explained this address before also in my theory. It's a special address. Why? Can any one of you please explain me why we are using this special address 127.0.0.1?
Sir, it is
Arpan?
used to connect to the same system.
Same system, yes. So if any outside router will ever pick this packet which contains an IP address destined for 127.0.0.1, it will simply drop it. It will never take it ahead. So network router will never entertain these packets. It is only for a single system. So within one system, two processes are there. They wants to communicate. Then you can destined with this address. You can have a destination address because now we just want to play with this process and there is no physical router in existence for us. So that's why it is convenient for us to experiment with this address. Otherwise, if we would have done it in our lab, instead of that lab, on one system you could have run a server, on another system you could have run the client, and then you could have a proper communication. Even in current setting, if we have static IPs, because we are running behind proxy servers and all, so many in between internet service providers are there, so they have so much complicated stuff regarding IP addressing. Otherwise, if we would have, if any two persons have static IP addresses, then instead of this 127, one person can run the server side program and another person can connect from any other across the globe. So that is also possible with the same program. The same program we can write if you two have static IPs. So instead of this, you can write this. Your operating system will make a packet out of it, would send it to the internet, and then finally, eventually, you will receive there because your server is always on. It is looking for the packet to come, and then will return back. So that is also possible.
Sir, I encountered a problem. It says the
What?
sys socket.h header file is not there.
Here's the header file you have to deal with why it is not there. Which header file is not there?
Socket.h.
Socket.h is not there. So look for a solution that how to include the header file. Okay, then you can do it on your pace. Next week we will meet. Whether you want to keep it on Sunday or on any other day, or whether Sunday is absolutely fine with you.
I feel Sundays are fine because we are not coming from two classes or something. We can just keep it in the evening.
Okay.
And then we can proceed. It will be easier for us. Like, sir, we wanted like in between CN classes, na? So it can be like a day before CN classes doesn't make much difference. On Tuesdays, like there are other classes, there might be tests and all in the coming weeks, so it will be better to have it
Okay,
on Sunday.
then we will go with Sunday only.
And Sundays, so we can like some people might have in the evening, we can have it in the afternoon or something, 1 p.m. or something, before lunch, after
The
breakfast,
time
and
we can decide later on, but we'll keep it on Sundays. Okay. Okay, then fine. Any one of you have done it? If you have any problem in understanding the current program, ask me again. Though I have explained it and break it down well, but still if you are feeling that somewhere you have an issue regarding understanding, you can ask me, then only I will leave. I hope that by next week or so, you will be able to do it. All the two programs. And this, Shikhar, this old manual is there with you or not? I think I have shared it with you.
already shared it, sir. So no.
It is there with you. There are other programs as well. If you can do it for one logic, other programs are also simple. One sort of thing is that client will share some information with server in encrypted form. So at the client side, when whatever the user will type, suppose if user is typing ABCD, a very simple algorithm for encryption you have to use, you have to convert A plus 4. So if A is written, so you have to convert A to A, B, C, D. You have to convert A to D, likewise B to E, and in this way. So it in the encrypted form, then you have to send it. At the server side, server will retrieve it, convert back it into the plain text, and then send the plain text to you. And at the receiving end, at the client end, then you have to retrieve that received item and show it to the user that this is something which you have encrypted again. into the plain text form. So that is another program, and one more program is there. So those are two additional exercises. If you are interested in doing those, you can go ahead with those additional stuff as well. Okay, hope you would have understood all these things, and
Yes, sir.
we'll see you tomorrow then.
Okay, sir.
Okay then.
That's